For this problem, we want to find the limit as x approaches 2, but the value x equals 2 is going to be a problem here. It's not going to be in the domain of the original function. So when we want to evaluate this limit, we need to do some sort of simplification before we can get started. We're actually able to factor the numerator, and what this does is it will cancel that factor. And so this is equivalent to finding the limit as x approaches 2. Even though this function is not defined at 2, we know what the function is doing as you approach 2, which is all that the limit's trying to find. So now we have the ability to simply plug in our 2, and the limit here is 4. The absolute value function is a little bit of a strange one. So you can actually define just that absolute value function using a piecewise function. The function will be equal to itself whenever what's inside the absolute value would be positive. And so that would happen for all values of x greater than or equal to 2. If you substitute values 2 or greater, what's inside the absolute value will be positive. And then when you're evaluating absolute value functions, if it's positive, it stays positive. The challenge is when x is less than that value, making negative values. Well, what the absolute value function actually does is it makes the opposite of what's inside when you are negative. So in this case, for all values less than 2, you get a negative function. So what we're doing in this function is we are defining it differently based on where we are on the number line. So we can define this as x minus 2 over x minus 2 when x is greater than or equal to 2. And we can define this as negative x minus 2 over x minus 2 when x is less than 2. Well, this simplifies, and the function is simply 1 when x is greater than 2, or negative 1 when x is less than 2. This function is fine for any values except for 2. At the value 2, it's switching from the right, it's going to be positive 1, and from the left, it's going to be negative 1. Graphically, it's going to look like this, and when you don't approach the same value from the left and from the right, the limit does not exist. So we can write this limit as x approaches 2 of this function does not exist. Part C has another piecewise defined function, but for this one, it's a little bit different from Part B, because here the function is defined as x squared for any value of x except 2. So if you come in from the left, it's going to be x squared. If you come in from the right, it's going to be x squared. It's just right there at x equals 2 that this function is going to be 0. Graphically, the function will be equal to x squared, except at this one point right here, the function is actually going to be defined as just 0. But for a limit, you're interested in what the function is doing around the x value. So around the x value, it's approaching what it would be on that x squared graph. So the limit here, as x approaches 2 of our function, is simply going to be 2 squared, or 4. It doesn't matter what the function actually equals at 2, as long as from the left and from the right, it's approaching the same value.